Hey everyone, welcome back to the Tech Think Tank. I'm Jenny and we're diving deep into the world of AWS interviews in today's episode 3 of Mastering AWS Interviews, the ultimate guide to the top 250 plus questions. If you're gearing up for an AWS interview or just looking to level up your knowledge in cloud computing, you're in the right place. In the previous episodes, we covered fundamental concepts, scenario-based questions, and even some real-world problem solving. But hold on tight because today, we're stepping it up a notch with a fresh set of challenging questions that will truly put your AWS skills to the test. And of course, if you haven't seen episodes 1 and 2 of this series, then here is your opportunity. Click the pop-up banner now or the link in the description below to watch it first. I recommend you watch these episodes first and then watch this video. Before we jump in, make sure you've subscribed to the channel and hit that notification bell, so you never miss out on valuable insights, tips, and tricks for acing your AWS interviews. Alright, let's not waste any time. Episode 3 of Mastering AWS Interviews starts now. And hey, if you find this video helpful or if you're excited about mastering AWS interviews, don't forget to give it a thumbs up, share it with your friends and colleagues who might benefit, and of course, hit that subscribe button. Your support means the world to us and helps us keep creating content like this. What is the difference between the classic load balancer and the application load balancer? The classic load balancer, CLB, in AWS operates at the transport layer, OSI layer 4, making routing decisions based on IP addresses and ports. It provides basic load balancing functionality with limited support for SSL termination and lacks features like WebSockets and HTTP/2. On the other hand, the application load balancer, ALB, operates at the application layer, OSI layer 7, enabling more advanced routing decisions based on content, such as URLs and headers. ALB supports modern web applications with features like WebSockets and HTTP/2, advanced SSL termination, and introduces target groups for flexible instance grouping and enhanced health checks. While CLB is suitable for straightforward load balancing needs, ALB offers more sophisticated features for complex application architectures. By default, how many IP addresses does AWS reserve in a subnet? In AWS, when you create a subnet, the first 4 IP addresses and the last IP address in the subnet CIDR block are reserved by AWS. These reserved IP addresses are used for various purposes, including 1. Network address. The first IP address is reserved as the network address. 2. VPC router. The second IP address is reserved for the VPC router. 3. DNS server. The third IP address is reserved for the DNS server. 4. Reserved for future use. The fourth IP address is reserved for future use by AWS. And 5. Broadcast address. The last IP address is reserved as the broadcast address. These reserved addresses are part of the /24 block for IPv4 subnets in AWS by default. It's important to be aware of these reserved addresses when planning your network configuration within a VPC. What is meant by subnet? In AWS, a subnet is a segmented portion of a virtual private cloud, VPC. It is a range of IP addresses in the VPC and acts as a logical unit within the larger network. Subnets help organize resources, enhance security, and facilitate better network management in the AWS cloud environment. How can you convert a public subnet to a private subnet? To convert a public subnet to a private subnet in AWS, you need to modify its routing configuration. Start by removing the route pointing to the Internet gateway in the subnet's associated route table. This ensures that instances in the subnet no longer have direct Internet access. Additionally, review and adjust network access control lists, NACLs, and security group settings to align with the new private subnet requirements. If your instances in the public subnet were using elastic IP addresses, consider disassociating them. Finally, verify the connectivity of instances within the subnet to ensure proper communication with other resources in the virtual private cloud, VPC. By making these adjustments, you transform the subnet from a public-facing configuration to a more secure, private subnet. Is it possible to reduce an EBS volume? Amazon EBS volumes cannot be directly reduced in size. However, you can achieve a reduction by creating a snapshot of the existing EBS volume, generating a new EBS volume with the desired smaller size, and then restoring the data from the snapshot to the new volume. After detaching the original volume from the instance, attach the new one, ensuring the same device name. Finally, resize the file system on your instance to recognize the adjusted volume size. It's essential to understand the potential downtime involved and thoroughly test the process in a safe environment. What is the use of Elastic IP? Are they charged by AWS? An Elastic IP (EIP) in AWS serves as a static IPv4 address that offers stability and flexibility in cloud computing environments. One of its key advantages is providing a persistent public IP address for Amazon EC2 instances. This proves valuable for scenarios where you require a fixed endpoint, such as hosting a web server or maintaining consistent access for external services. Additionally, EIPs facilitate seamless recovery by allowing quick reassociation with another running instance in the event of instance failure or during instance stop and restart operations. They are particularly useful for instances that require outbound internet access in a virtual private cloud, VPC, enabling communication through network address translation, NAT. While EIPs offer these benefits, it's important to note that they are charged by AWS when allocated but not associated with a running instance, or when associated with a stopped or terminated instance. To optimize costs, it's recommended to release Elastic IPs when not in active use. As AWS pricing can evolve, users should refer to the official AWS website for the latest and most accurate information regarding Elastic IP charges. One of my S3 buckets is deleted, but I need to restore it. Is there any possible way to do this? If your Amazon S3 bucket has been accidentally deleted, recovery options depend on certain factors. First, check if versioning was enabled on the bucket before the deletion. If versioning was active, you can potentially restore deleted objects by navigating to the Versions tab in the S3 console. If versioning wasn't enabled, the chances of recovery are more limited. You may want to explore using the AWS Command Line Interface, CLI, or SDKs to check for the existence of the deleted bucket and attempt restoration if possible. However, if these steps do not yield the desired results, consider reaching out to AWS support for additional assistance. It's essential to act promptly, as AWS does not guarantee the recovery of deleted S3 buckets, especially without versioning. Regularly backing up critical data and implementing versioning can mitigate the risk of data loss in the future. When I try to launch an EC2 instance, I get the service limit exceeded. How to fix the issue? Encountering a service limit exceeded error while attempting to launch an EC2 instance indicates that your AWS account has reached the predefined limit set by AWS for the number of instances you can run in a specific region or for a particular instance type. To address this issue, you can take several steps. Begin by identifying the specific service limit that has been exceeded by checking the AWS Service Quotas page in the AWS Management Console. This page provides a comprehensive view of your current resource usage and limits for various AWS services, including EC2 instances. Once you've identified the limit in question, you have a couple of options. If the existing limit is insufficient for your needs, you can request a limit increase through AWS support. Submit a request detailing your use case, workload, and reasons for the increase. AWS support will review your request, and if approved, they will adjust the limit accordingly. Additionally, assess your current EC2 instances and consider terminating any unused or underutilized instances to free up capacity and temporarily alleviate the limit exceeded issue. Regularly monitoring your resource usage and aligning your limits with your evolving requirements is crucial for efficient AWS resource management and to prevent service limit challenges in the future. I need to modify the EBS volumes in Linux and Windows. Is it even possible? Yes, it is possible to modify Elastic Block Store (EBS) volumes on both Linux and Windows instances in Amazon EC2. In Linux, you can use utilities like fdisk or parted to resize partitions and file systems on an EBS volume. After resizing the partition, you may need to use the resize 2fs command for extension 2, extension 3, or extension 4 file systems or other relevant commands for different file system types. On Windows instances, you can use the disk management tool to extend or shrink volumes. To extend a volume, right-click on the volume, select Extend Volume, and follow the wizard to increase the volume size. For shrinking volumes, the process involves using third-party tools since the disk management tool typically doesn't allow for direct volume reduction. Before attempting any modifications, it's crucial to create backups of your data and understand the specific file system and partitioning tools relevant to your operating system. Also, ensure that your instance is stopped before attempting to modify the root EBS volume. In summary, adjusting EBS volumes on both Linux and Windows instances is possible, but the specific commands and tools vary between the two operating systems. Is it even possible to stop an RDS instance, and how can I do that? Yes, it is possible to stop an Amazon RDS, Relational Database Service, instance. However, it's important to note that stopping an RDS instance is different from stopping an EC2 instance, and the option to stop may not be available for all database engines. To stop an RDS instance, navigate to the AWS Management Console and open the RDS dashboard. Then select the RDS instance you want to stop. In the Instance Actions drop-down menu, you may find an option called Stop. If this option is available for your specific database engine, you can use it to stop the instance. Stopping an RDS instance involves freezing the state of the instance and preserving its data, which is different from terminating an instance. While stopped, you won't incur charges for the compute resources, but storage charges still apply. Keep in mind that not all database engines support the stop option. For example, MySQL, PostgreSQL, and MariaDB instances can be stopped, but Oracle and SQL Server instances cannot. Before stopping an RDS instance, it's recommended to check the AWS documentation specific to your database engine for any engine-specific considerations or limitations. Additionally, consider creating a manual backup before making any significant changes to your RDS instance. What is meant by parameter groups in RDS? And what is the use of it? In Amazon RDS, a parameter group is a configuration set that defines the runtime behavior of a database engine. It consists of a collection of parameters, each representing a specific aspect of the database's functionality. These parameters can influence performance, resource allocation, and various operational aspects. Parameter groups are database engine-specific, tailored to the characteristics of engines like MySQL, PostgreSQL, Oracle, SQL Server, etc. The primary purpose of parameter groups is to provide a structured and efficient way to manage and customize database configurations. By utilizing parameter groups, database administrators can fine-tune the behavior of their RDS instances to align with specific application requirements and workload patterns. This level of customization enables adjustments to memory allocation, query optimization, caching strategies, and other critical settings without the need for extensive manual intervention. Furthermore, parameter groups facilitate consistency across multiple DB instances by allowing administrators to associate the same set of configurations with different instances, ensuring a standardized environment. Whether it's dynamically modifying parameters without restarting the instance or making static adjustments that require a restart, parameter groups provide a versatile mechanism for efficient configuration management within the RDS service. What is the use of tags and how they are useful? Tags in AWS serve as key value pairs that provide metadata for various AWS resources. They offer a flexible and powerful way to organize, categorize, and manage resources within a cloud environment. Tags are applied to resources such as instances, volumes, and databases, allowing users to add contextual information beyond basic attributes. One significant advantage of tags is their role in cost allocation and management. Moreover, tags are essential for automation and resource lifecycle management. They are commonly used in scripts and policies to make automated decisions, enforce policies, and trigger workflows based on resource attributes. Tags also provide operational insights by adding context to resources and indicating details such as environment type, project names, or owners. They contribute to access control through integration with IAM policies, allowing for fine-grained permissions based on tagged attributes. The AWS Management Console and CLI support easy resource search and filtering based on tags, enabling efficient resource navigation and management. Establishing a consistent tagging strategy aligning with organizational goals ensures effective resource organization, cost monitoring, and streamlined operations in the AWS cloud. I am viewing an AWS console, but I'm unable to launch the instance. I received an IAM error. How can I rectify it? Encountering an IAM error while attempting to launch an instance in the AWS Management Console often points to issues with the permissions associated with your IAM user or role. To address this, first, review the IAM permissions granted to your user or role, ensuring that it includes the necessary permissions for launching EC2 instances, specifically the EC2 Run Instances permission. Additionally, check your EC2 service limits to ensure you haven't exceeded the allowed number of instances. If you're assuming a role to launch instances, inspect the trust relationships associated with that role to confirm that your IAM user is authorized to assume the role. If the error persists, carefully examine the specific details of the IAM error message provided in the AWS Management Console. This information can offer more insights into the exact nature of the permission or trust relationship issue. Temporarily granting broader permissions to your IAM user can serve as a troubleshooting step to identify the specific permissions required for a successful instance launch. However, it's crucial to refine these permissions based on the principle of least privilege once the issue is resolved. If the problem persists or if adjustments to IAM policies are necessary, consider involving your AWS account administrator or IAM administrator for a more in-depth review and resolution of the IAM-related error. I don't want my AWS account ID to be exposed to users. How can I avoid it? To prevent exposing your AWS account ID to users, you can implement several best practices for managing access and ensuring security within your AWS environment. Firstly, leverage AWS Identity and Access Management (IAM) to grant users and services only the permissions they need, following the principle of least privilege. When defining IAM policies, avoid including the AWS account ID as a resource identifier whenever possible. Additionally, consider using AWS resource names and Amazon resource names, ARNs, rather than explicit IDs in your configurations. ARNs provide a more abstract and flexible way to refer to resources, allowing you to avoid direct exposure to sensitive information like the account ID. Regularly review and audit your IAM policies to ensure that they align with your security requirements and that no unnecessary information is exposed. Furthermore, if you are interacting with AWS services programmatically or through the AWS Command Line Interface (CLI), consider using AWS Identity Federation, such as AWS Security Token Service (STS), with temporary security credentials. This approach can help you limit the exposure of long-term credentials and reduce the risk of accidental disclosure. Lastly, educate your team members and users about the importance of avoiding the explicit exposure of AWS account IDs and sensitive information. Implementing a combination of these measures will contribute to a more secure AWS environment while safeguarding your account ID from unnecessary exposure. By default, how many elastic IP addresses does AWS offer? AWS provides 5 elastic IP addresses by default for each AWS account, as long as those IPs are associated with instances. If an elastic IP is disassociated from an instance, it is charged at an hourly rate until it is reassociated or released. Okay, so you have enabled a sticky session in ELB. Let us see, what does it do with your instance? Enabling sticky sessions on an elastic load balancer, ELB, in AWS ensures that requests from a specific client are consistently directed to the same backend instance throughout the duration of a session. This session affinity feature, also known as session persistence, is valuable in scenarios where maintaining session state or connection persistence is essential for the proper functioning of an application. When a client establishes a connection with the load balancer assigns the client to a specific backend instance based on configured criteria, such as the source IP address. Subsequent requests from that client are then directed to the same backend instance for the duration of the session, either until the configured timeout is reached or until the client closes the session. This is particularly useful for applications that rely on preserving session state or storing user-specific data on a specific instance. While sticky sessions ensure session continuity, it's important to be aware that they may impact the load balancer's ability to evenly distribute traffic among instances. This consideration becomes significant when scaling the infrastructure, as certain instances might handle more traffic than others if sticky sessions are in use. As with any feature, the decision to enable sticky sessions should align with the specific requirements of the application and the desired balance between session persistence and load distribution. Which type of load balancer makes routing decisions at either the transport layer or the application layer and supports either EC2 or VPC? The type of load balancer that makes routing decisions at either the transport layer, layer 4, or the application layer, layer 7, and supports both EC2, Elastic Compute Cloud, and VPC, Virtual Private Cloud, in AWS is the Application Load Balancer, ALB. The Application Load Balancer operates at layer 7 of the OSI model, making it capable of understanding and making routing decisions based on the content of the application, such as HTTP or HTTPS requests. This makes it well-suited for routing traffic to different backend services based on content, paths, or host names. ALBs are part of the Elastic Load Balancing (ELB) service in AWS and provide advanced routing features, content-based routing, and support for multiple services on a single load balancer. They can distribute incoming application traffic across multiple targets, such as EC2 instances, containers, and IP addresses, within one or more availability zones in a VPC. In summary, the Application Load Balancer is the AWS service that operates at both the transport layer and the application layer, supporting routing decisions based on content, and it is compatible with both EC2 instances and virtual private cloud environments. Which virtual network interface can you attach to an instance in a VPC? The virtual network interface that can be attached to an instance in a virtual private cloud, VPC, is known as an Elastic Network Interface, ENI. An ENI acts as a virtual network card, providing networking capabilities for EC2 instances within the VPC. With ENIs, users have the flexibility to attach multiple interfaces to an EC2 instance, each with its unique private IP address, and optional public IP address if applicable. This feature allows for more versatile networking configurations to meet the specific requirements of applications and services running on the instance. ENIs offer additional advantages, including the ability to associate them with elastic IP addresses for static public-facing communication, and the capability to attach and detach them from instances dynamically. Furthermore, ENIs are integral components for enhancing the security of attached instances, as they can be associated with security groups and network ACLs to control inbound and outbound traffic. Additionally, ENIs play a crucial role in supporting advanced networking features such as elastic load balancing, ELB, Amazon RDS, and AWS Lambda, enabling the creation of sophisticated and scalable network architectures within the AWS cloud environment. Understanding how to effectively utilize and manage ENIs is fundamental for optimizing networking configurations and ensuring the reliability and performance of applications in a VPC. Alright, so you have launched a Linux instance in AWS EC2. While configuring the security group, you have selected SSH, HTTP, and HTTPS protocols. Why do we need to select SSH? Selecting the SSH, Secure Shell, protocol when configuring the security group for a Linux instance in AWS EC2 is essential for enabling secure remote access to the instance. SSH is a cryptographic network protocol that allows users to connect to a remote server securely. By including SSH in the security group rules, you are permitting inbound traffic on the default SSH port, usually port 22, to reach the Linux instance. This is particularly crucial for Linux instances, as SSH is the standard method for administrators to log in and manage the server remotely. Without SSH access, it would be challenging to perform tasks like configuration, updates, and troubleshooting on the Linux instance. By explicitly allowing SSH traffic in the security group settings, you ensure that authorized users can establish secure connections to the Linux instance, maintaining the integrity and security of the server. You have chosen a Windows instance with Classic and you want to make some changes to the security group. How will these changes be effective? When making changes to the security group of a Windows instance in AWS, the modifications take effect immediately. The security group acts as a virtual firewall that controls inbound and outbound traffic to the associated instances. Therefore, any adjustments made to the security group rules, such as adding or removing inbound or outbound permissions, become effective without requiring a restart of the Windows instance. For example, if you decide to allow Remote Desktop Protocol (RDP) traffic by adding a rule to permit incoming connections on port 3389 in the security group, the change will be applied instantly. Similarly, if you decide to restrict certain outbound traffic by modifying egress rules, those changes will also take effect immediately. This flexibility allows you to adapt the security group configurations dynamically based on your requirements without interrupting the operation of the Windows instance. It's important to note that while changes to security group rules are immediate, certain changes, such as modifying the security group associated with an instance, may briefly interrupt network connectivity as the changes are applied. Always ensure that modifications align with your security policies and the intended functionality of the Windows instance. Under which category of cloud services do load balancers and DNS services fall in AWS? In Amazon Web Services (AWS), the load balancer and DNS services fall under the category of infrastructure as a service (IaaS) and are part of the broader AWS offerings. In summary, both the load balancer, elastic load balancing, and DNS service, Amazon Route 53, in AWS are integral components of the IaaS offerings, providing users with scalable and reliable solutions for load balancing and domain name management. You have an EC2 instance that has an unencrypted volume and you want to create another encrypted volume from this unencrypted volume. Let us see how we can achieve this. To create an encrypted volume from an existing unencrypted volume in AWS, you can follow a series of steps. First, initiate the process by creating a snapshot of the unencrypted volume. A snapshot serves as a point-in-time copy of the volume, capturing its data and configuration. After creating the snapshot, proceed to copy it, specifying encryption settings during the copy operation. This action generates an encrypted snapshot. With the encrypted snapshot in place, you can then create a new encrypted volume based on this snapshot. During the volume creation, you will be prompted to select the encrypted snapshot as the source. Once the new encrypted volume is created, you can attach it to your EC2 instance. Ensure that your EC2 instance supports the chosen encryption type and that appropriate IAM roles and policies are configured. It's important to note that this process involves the creation of a new encrypted volume rather than directly encrypting the existing unencrypted volume. Depending on your use case, you may need to plan for potential downtime or implement a strategy for data migration if the encrypted volume is intended to replace the existing unencrypted one. Additionally, be mindful of any necessary updates to your instance configurations, file systems, or applications to recognize and utilize the newly created encrypted volume. Always adhere to best practices for data backup and consider the specific requirements of your workload during the volume encryption process. Where does the user specify the maximum number of instances in the autoscaling commands? In AWS autoscaling, the user specifies the maximum number of instances using the max size parameter in the autoscaling commands. The max size parameter allows the user to set the upper limit on the number of instances that can be launched by the autoscaling group. For example, when creating or updating an autoscaling group using the AWS command line interface or SDKs, you would include the max size parameter followed by the desired maximum number of instances. Here's an example of the AWS autoscaling create autoscaling group command. In this example, max size 5 specifies that the maximum number of instances allowed in the autoscaling group is 5. Adjust the value according to your scalability requirements. The max size parameter helps ensure that the autoscaling group doesn't exceed a specified capacity, providing control over resource scaling in response to changing demand. What are the types of Amazon machine images provided by AWS? AMIs in AWS come in several types, catering to diverse user needs. Firstly, Amazon-provided AMIs are pre-configured images maintained and updated by AWS, offering a quick and reliable option for launching instances with popular operating systems like Amazon Linux, Ubuntu, and Windows Server. Secondly, community AMIs, on the other hand, are shared by the AWS community, allowing users to benefit from a wide array of configurations contributed by other users. Thirdly, AWS Marketplace AMIs are available from third-party vendors and ISVs on the AWS Marketplace, often featuring pre-configured software solutions or specialized stacks. Users can explore and deploy these AMIs based on their specific application requirements, and some may involve additional costs. And lastly, private AMIs are custom images created by users to capture specific configurations and applications. Stored within the user's AWS account, these AMIs are ideal for maintaining consistent setups across instances within an organization. Additionally, users can choose to share their custom AMIs with specific AWS accounts or the public, fostering collaboration and knowledge sharing. These varied types of AMIs offer users flexibility and choice when provisioning Amazon EC2 instances, enabling them to select images that align with their specific use cases, preferences, and infrastructure requirements. After configuring Elastic Load Balancer, you need to ensure that the user requests are always attached to a single instance. What setting can you use? To ensure that user requests are consistently directed to a single instance after configuring an Elastic Load Balancer, ELB, in AWS, you can utilize the stickiness or session affinity feature. This setting enables the load balancer to bind a user session to a specific backend instance, ensuring that subsequent requests from the same user are consistently routed to the chosen instance. To ensure that user requests are consistently directed to a single instance after configuring an Elastic Load Balancer, ELB, in AWS, you can utilize the stickiness or session affinity feature. This setting enables the load balancer to bind a user session to a specific backend instance, ensuring that subsequent requests from the same user are consistently routed to the chosen instance. In conclusion, mastering AWS interviews is an ongoing journey, and I hope this episode has provided valuable insights into tackling some of the top 250+ questions that often arise during AWS interviews. Remember, continuous learning and hands-on experience are key to building confidence in your AWS skills. If you found this video helpful, don't forget to like, share, and subscribe for more content. Feel free to comment below with any specific topics or questions you'd like us to cover in future episodes. Thank you for joining us on this AWS Interview Mastery Series, and best of luck with your AWS career endeavors. Happy cloud computing! See you all in the next episode soon here in the Tech Think Tank. Until then, stay curious and keep on thinking.